Hello viewers, welcome back to my channel. This is John from Cloud Tech Insights. Today's topic of discussion is SoAL local testing. This is another series on Spark on Lambda. One of the key topics that I really want to educate the users that you can test Spark on Lambda locally on your Cloud9 or IDE, which has access to the AWS resources, especially the source and target system that you're trying to connect, without deploying it to a Lambda right away. So you can test it locally. I would say you can clone it locally, build the Docker container, and then trigger the Docker container just like a Lambda script, and then see if it's working, if it's exactly meeting your requirements, and then deploy this to Lambda. This would save a lot of cost by not deploying on Lambda. Sometimes if you're not within the free tier limit, it costs the Lambda execution. So let's get started. Let me show how you can do a local testing on a Cloud9. That's one of the IDE of my choice, and it has connection to all the AWS resources. Into the Cloud9, I just wanted to say I created two folder for the target location for the iceberg table, as well as ported the iceberg script. So in this example, I'm going to be using iceberg. That's one of the popular requests from my users. So I'm imported the script, which is available on the GitHub repository. So if you look at the GitHub repository right here, it has the Spark scripts, and it has all the scripts for different frameworks, as well as the sample file. And this sample file is a commonly available sample file from a location, which is much easier to grab than locally uploading it. So moving on to Cloud9 right here. So the very first step is open a terminal, clone your repository. So I'm cloning the repository, exactly copying the repository address and git cloning it onto a local folder here. So it takes up to a minute sometimes, and it captures all the files, subfolders, everything into a local directory. Once it's in the local directory, which is right here, and we can see the local directory here with the same similar structure as the GitHub. I would cd it into the local directory. Now I'm in the local directory right here. You can see all the files. I can have the Docker file here. So we are in the Docker file. So when you are in the Docker file section, as per the local execution, which is under the wiki page on the side, all the way here, local testing, the next first step is to execute the Docker build command. So once you're in the Docker, copy the Docker build command, you go to the Cloud9 and paste the command here. So in this example, I provided Delta, so you can always change it to iceberg. So this is just to ensure that the container size limits lower. We don't want a bigger container, so we only install what we need. But it's up to you whether to install all the 3 frameworks or just 2 frameworks. We have made some changes around this area in the release point 3.0, and this is how we ensure that iceberg is compatible with the Spark on Lambda. Okay, so it builds the framework, and the build is finished because I already have this container built previously, so it used the cache to build rest of the framework. So one thing I would say is there are some times that space may not be right for the Cloud9, so you probably have to go to the EC2 instance and extend the space within the EC2 instances. So let me quickly go through the script before the execution. So I picked the iceberg script in this demo. So I have all the information here. I overwrote the input and the output path. This is a common location where you can get the accommodations files from, or you can just download and point it to the right S3 folder. I would say S3A is required. That's a API via the Spark accesses. It's one of the faster APIs, the Spark access and retrieve the information from S3. So if there are users who say I cannot read it from the S3 location, really look into the prefix. It should be S3A. Ensure that is the case. And then we move on to the script, and this is where the instance is created. And then we have the reader script here, and then it provides once it reads the file, it provides a schema, and then it starts creating a Spark table, a local table. And once the local table is created, it uses a SQL to create the iceberg table DDL. Once the iceberg TDL is created, there is an insert into command from the local Spark table to the iceberg table. And this is executed by spark.sql commands here. And once the script executes, you will see a table within the glue catalog, and ensure that in the glue catalog, you create a database called Spark on Lambda so that it can immediately write it into that table. So this is where the catalog database name is. So you can always change the name, or you can have your own database name created here. So moving on to the execution. So we have uploaded the script into the S3 location, and now we are executing the Docker run command, which I showed in the local testing dot the local testing. So there you go to the local testing here, and this is the script I'm talking about. So provide your S3 bucket name and the folder and the location of the script, and rest everything is dynamic in nature, so you don't have to change any of those information. So you look at the information, I put the script name. I didn't have a folder, so I didn't put a folder name there, and I gave the bucket name. This is my bucket name, and rest all information will be captured based on your access level of your Cloud9. So once you execute this, you can see, let's see what's going on. So it's already failing, the port is already allocated. So there is like a Docker PS, let me see, let me kill all these container, Docker stuff. Okay, let's do Docker PS again to make sure. Okay, now we run the command. So now the port is free. The port is using 880, and now it's ready for execution. Now it's looking for a trigger, an external trigger that can trigger the Spark or Lambda job. So open a new terminal, go back to the local testing, and this is the trigger command, the curl. Copy the curl command, come back to the terminal, execute the curl command. Now you trigger the script, so you can see it executing locally. This is all happening locally within your Cloud9. So there you go. We have the execution log right here. So it got triggered, and then there was an error before. I resubmitted the job. It was because so I deleted the table. Now it's a clean slate. So you can see an execution log right here. And the first step, it produced the schema of the file as per the script, and it shows it's writing the target iceberg table to this particular location. So if you're repeating some of these things, sometimes you might have to delete the underlying metadata file. So ensure that either you are overwriting or inserting based on your requirements. You have to understand that you to clean up those metadata files for iceberg. So it picks up the Redshift spatial accommodation file, which is publicly available, and it starts its process and it completes its process right here. Successfully stopped the Spark context, the system stop, the S3A file system, everything. So it's ready for the next execution. So if you can trigger again to execute the same job, but in this demo, I just want to stop right here and show where the file is. So under the Spark on Lambda glue database, I'm looking for the Spark on Lambda. There it is. The table is right here. The accommodation underscore iceberg is produced. The database is Spark on Lambda, and the location is S3A iceberg demo. Okay, so this is how you test it locally, see if it meets your requirement, and once it's done, you move it to or deploy it to AWS Lambda. That concludes our session. Like I mentioned before, this video does not have any affiliation to AWS nor share any opinion or thoughts from AWS. It's just a personal opinion, and I will be creating additional videos on other components of Spark on Lambda, so please stay tuned. I will provide more information. Please subscribe my channel. Thank you for watching.